we are given P2. In our case, this vector space is a vector space of all polynomial of degree at most 2. So P2 is a set of all polynomial of degree at most 2. So this is a vector space, and a general polynomial or a general element in that vector space is the polynomial of the form a0 plus a1t plus a2t squared. And this transformation t is from P2 to P2. It sends this polynomial to this one. We need to find the matrix representation of t relative to the basic B, the standard basics. B is the standard basics for P2. So, in general, the transformation T from a vector space V to the vector space V, B is any basics. So let me say B1 to Bn. If V is an n-dimensional vector space, a basics contains B vector and contains n vectors. The matrix representation of T relative to B is denoted by T with a square bracket B. This matrix can be computed as the first column is a coordinate of the first vectors relative to the basics, and you do the same thing for all the other columns. T, B, N, B. So the first step, you compute the image of B1, and you do the same for B2, B3, B4 up until Bn, and then you compute the coordinate. The coordinates T of B1. So you know that T of B1 is a vector in this vector space V. It can be written as linear combination of these n vectors. So let me say T of B1, T of B1. Assume that this is A0. No. Let me call the coefficient 0 or 1 vector B1, coefficient 2 vector B2 up until coefficient n vector Bn. Then the coordinate T of B1 related to B is just the coefficient C1 up until Cn. And then you put this in the first columns. You do the same thing up until the last column and you are done. So that's how we do it. In our case, they give us the transformation. Now let's do it for this specific standards basics. We have 3 vectors in the basics. Now what I need to compute is compute the image of all the vectors. So the first vector is 1. This number 1 here you think of as the polynomial, because this is a polynomial in the vector space P2. So this is a polynomial 1 plus 0t plus 0t squared, right? It sends any t to 1. So for any value of t, this one has only give us a value of 1. So for all value of t, 1 of these is always 1. So this is a polynomial in P2. Same for t and t squared. So in our case, a0 is just 1 times 1. So a0 is 1. In our case, look at this. We have a0, a1, a2. So let me copy it here. a0 is 1. a0 is 1. The constant. a0 times 1. a1 is 0 and a2 is 0. By definition of transformation t send that to this polynomial. So definition t is a transformation. Send this polynomial to this one. This is the definition of t. For each question, they give us a different formula, but this is the image of this polynomial. So now we compute what t of 1 is. So 1 is this polynomial. 1 equal to this. The image of 1 can be computed as 3 times a0. In our case, a0 is 1. So 3 times a0 plus 9 times a0 minus 2 times a1 plus 5 times a1 plus 8 times a2. Yeah, so we just plug in. a0 is 1, a1 is 0, a2 is also 0 into the formula. So plug in this formula. So in our case, we have t of 1 can be computed as 3 times a0, 3 times 1, 9 times a0, 2 times a1 times t, 5 times a1, 8 times a0, t squared. Yeah. So basically that's this one, and this is equal to 3 times 1, 9 times t, 0 times t squared. That you have the image of 1. The second step, we need to compute the coordinate of that image. Coordinate of t of 1 related to b is just the coefficient, because the 3 vectors is the 3 vectors in the basics. 1, t squared are 3 vectors in this basics b. The coefficient c1, c2, cn give us the coordinate. In our case, c1, c2, cn. 3, 9, 0. So this is the first column of the matrix. You do the same for the last 2 columns. Now t of 1 is done. T of t. T of t. So what does that even mean? Image of t. T is a polynomial, which is an element in P2. So 0 times 1, 1 times t, 0 times t squared. So in our case, for this A0, A1, A2, A0 is 0, A1 is 1, and A2 is 0. So A0 is 0, A1 is 1, A2 0. So here the definition of T, what we need to do is just plug it in. So 3 times A0, 3 times 0, 9 times A0, 2 times A1, T, 5 times A1, 8 times A2, T squared, which is 3 times 0, 0, 9 times 0, 0, minus 2t, minus 2t, plus 5t squared. This one, the coefficient gives us coordinate of t. So the coordinate t of small t relative to b is the column vectors with the coefficient 0 times 1 minus 2 times t plus 5 times t squared, which is 0 minus 2, 5. The first 0 is just 0 times the first vectors, which is 1 in the basics, 0 minus 2, 5, and we have done image of 1, compute the coordinate, image of t, compute the coordinate, the last vectors in the basics, image of t squared. Similarly, you will do image of t squared by the definition 3 times A0, so in our case A0 is 0, A1 is 0, A2 is 1. Now you get used to that, you don't need to write this down, but this is 0 times 1, 0 times t, 1 times t squared. A0, A1, A2, 3 times 0, 9, 0, 2, 0, 5, 0, 8, 1, t squared, 3 times 0, 0, 0 t. This is actually 0 times 1 and 8 t squared. The coordinate is just a coefficient. T squared will to be the coefficient 0, 0, 8. And by definition, the matrix, the representation of T related to B, is a matrix with 3 columns. 3, 9, 0. The first column, 0, minus 2, 5. Second column, and the last column. So you do the same for any other question. This is the answer. So recall for any other question. If they give us a transformation, they give us a basics for V, we compute the matrix, compute the image of its H vector in the basics, compute the coordinates of H image, put it in the columns. Này, we đã